Howdy fellow Trigger Trappers, I'm Michael aka Krizacho of Trigger Trap, and I'm going to talk a bit about the Trigger Trap hardware. As you may know, Trigger Trap hardware comes in both a TT version K Arduino Shield and a TT version 1 Arduino standalone device. While these two variants share most of the same subsystems, the device variant has considerable engineering focus on low power and consequentially long battery life operation. The Trigger Trap circuit design and PCB layout was done with CADSoft Eagle. It's a widely used package among hobbyists and professionals alike, and they have a free version available on their website cadsoft.de or cadsoftusa.com. With that in mind, we'll have a look at the TT version K Shield using Eagle CAD. As you can see in the schematic, the various systems are arranged into groups, starting with the sensor inputs. The sound sensor consists of a microphone AC coupled to a common emitter amplifier. This setup greatly increases the sensitivity. Moving on to the right is the light sensor and the laser sensor, both of which are phototransistors, and the upper leg of a divider. They are in fact current output devices, as the output voltage is set by the lower bias resistor. It can be seen that these are very similar, but in fact different parts with specific characteristics suiting them to purpose. Also seen here is the bypass capacitor for the analog reference pin. And in the same direction, moving along, we have the camera connector. There's not much to see here. It's optically isolated, common emitter. Then we have the aux input with optional pull-up resistor. As this input leads to pin A0 on the Arduino, the 5K1 resistor provides some protection in the way of series current limiting. There are multiple examples on the Get Satisfaction forum on how to connect and use the aux port. You can find a link to that forum at the end of the video. Up in the bottom row is the infrared emitter, which is used to send IR codes to cameras wirelessly. It's low side switched by way of a small signal N-channel MOSFET, the BS170. The MOSFET should not be left floating, so there's a pull down resistor on here, and the other resistor up here is current limiting the IR LED. The top row consists mainly of user interface. On the right are the buttons. Each one has a smoothing cap to negate the bounce in software. Not seen on each button is the pull-up resistor though, which is enabled internally in the microcontroller. The final bit is the LCD, which has three parts in the shield. The first being the LCD, the second being the serial shift register. As not all the microcontroller pins are available on the Arduino, we use the serial shift register to drive the LCD to reduce the number of I/O pins. The third part is the contrast voltage setting, and it's set with a resistor and a Zener diode here. This combination is far more temperature stable than purely resistive divider. A quick peek at the PCB layout will enable polygons. The analog section is down here on the right. The rest of the board is digital. Buttons are here. Bolt cap is here. Serial shift register is here. Optocoupler up here and cam there. And that's basically the Arduino Shield. So, moving on to the Trigger Trap version 1 device, we'll only look at what's different from the Shield here. The first and obvious thing is that it has two circuit boards, where the top one acts as a touch interface. This interface is achieved with an Atmel touch controller. That can be seen right here. The AT42QT1070, it's a smart device that resides in the I2C bus and handles the capacitive touch control. And here's what the top PCB looks like. Buttons, touch controller, and a connector. The bottom schematic looks a lot like the TT version K Shield with some notable differences. Mainly as a result of being battery powered, there's a physical power switch down here, and to the right of that we have a P-channel MOSFET here that's actually used to cut power to unnecessary components during time lapse. This allows for continual 5-month plus running time for time-lapse sequences. The camera interface, very much the same as the Shield. The infrared transmitter, also the same. We have additionally a reset button here, but that's not connected, it's not required. The auxiliary connector, also the same. To wrap up the bottom row, we have bridge connector that leads to the top PCB, and we have a programming header. It's this programming header that's used to put the bootloader onto the microcontroller. Moving up, we have the USB section. This is not shown in the Shield as it's part of the Arduino, but here it is. It's the standard USB to serial converter based on the FT232RL, and it facilitates uploading custom code to the inbuilt Arduino. Unlike the Shield, the LCD does not use a serial shift register. We had just enough pins on this to run it in 4-bit parallel mode directly to the microcontroller. Worthy of special note is the contrast control. The negative voltage that sets a readable display contrast on the LCD is directly related to the battery voltage. As the entire device is battery powered without a voltage regulator, the contrast voltage requires that the battery voltage is measured and equated to a PWM duty cycle for the negative charge pump. It's a little bit complex, but it's definitely my favorite part of the system. Moving left now, the analog sensors are much the same. Additionally, there is a resistive divider to measure the battery voltage. That's used for the contrast setting. As these resistors are really high, the impedance is matched with C13 here. It's a small capacitor. And we also have the option of setting an external voltage reference, but it's not required. And finally, wrapping up the schematic, we have the heart of the system. It's a ATmega 328 microcontroller. It's preloaded with the Arduino bootloader, and it's running at 8 MHz to best conserve power. Finally, the layout, which pays close attention to power routing and isolation for low analog noise. At the bottom, we have our connectors, the USB to serial converter, a couple of thick power traces, the microcontroller, LCD header, and the analog section is over here. If I enable polygons, we get a different view, and that's all there is to it. Further questions can be directed to the Get Satisfaction forum. Thank you, and enjoy your trigger trap.